Be Yahoo Finance API training part 2, and this time we're going to go into a beginner options pricing model, and we're going to use the GARCH model. And what that does is it allows you to find price mismatches amongst volatility, based on volatility. All right, so we're going to start this now. First, you need to import these libraries here. The Arch model, which we're going to use for the GARCH model, get it, GARCH, Arch, is has documentation here. You can read about it through here. Google search it, figure that out. All right, so we're going to import these libraries here, and now we got to get the data from Yahoo. And what I'm going to do is I'm going to create variables here, ticker, and this is, I'm going to use Tesla, and there's a reason I'm using Tesla. You'll see later. Specific reason why I got to use Tesla, because I'm kind of lazy. And you'll see why. I'm going to have the start date at the beginning of this year for the data, and the end date, because we're using historical data, which Yahoo Finance is great at, I'm going to be using last Friday. So time of this recording, last Friday was the 9th. And we're going to create another variable for the actual data, ys.download, the ticker, sorry, and the ticker start. On that, data is loaded. Let's see what the data prints out. Cool. Gives you a nice stock data with all of these values. All right. And now we need to actually get these simple returns for the stock data. So this is actually a cool lesson if you guys want to see how simple returns are calculated. So I got to get the adjusted closes from this column here, and I'm going to put it into this variable adjusted closes. So data, and in this we're going to go to get the adjusted close column, close, capital C, perfect. Okay, that, okay, cool. Now the returns are going to, this is the simple return, is going to be 100 times this variable here, which is the adjusted close prices. And then we got to get the percent change of this. And then we got to drop any values. Any values are just values that symbolize not a number. So anything that's not a number is going to show up as NA, so non-numerical values, which is annoying. So if you're into data engineering, get rid of those things anytime you see them by utilizing this right here, the syntax right here. So now let's see what return spits out. Here are the returns for the adjusted close column. Awesome. So this is the simple returns right here. Again, a great thing if you want to learn about simple returns, calculating simple returns for stocks. Now let's get the model set up. All right, and now we're going to do the model equals Arch model, and we're going to put our returns, our simple returns in here. All right, cool. So now we're fitting the returns to the model. Now we're fitting it now. Model.fit, because we just inputted the returns into the model. So now we just got to fit it within the model. All right, boom. So you see, look, the GARCH model information is here, which is what we wanted. Additionally, you can also look up the summary as well. If you're curious to see what else is going to spit out. So there it is. All right. Now let's get into forecasting, because we got to get to the actual annualized volatility price, and that's where we're going to compare with the historical volatility. So we got to do forecast equals res that forecast, and we're going to do some equals 1, pre-index equals false. Oh. All right. Now, VR, which is the variance forecast, and that's going to equal forecast, which is up here, this variable here, dot variance. Forecast that variance that I lock. So we're gonna actually be indexing for the values placed in first. Right. And if you want to take a look at what that spits out, you can actually just return this, run it, boom, there you go. So now we got to get the annual. So now we got to get the volatility. Sorry, volatility. I'm gonna say that's forecast. So to get that, I'm just gonna do vol equals vol forecast equals np dot. You got to get the square root of the VR forecast. And NumPy's package is great for that. All right. We run this, and you can spit it out too if you want to check out what it is. Boom, there we go. Now we got to get the annualized. And that's basically when you're going to, I'm going to put n forecast. I spelled that wrong. That's basically, you got to get the trading years. So you got to get trading days for the year. So if you know there's 252 trading days. So we got to do the volatility forecast times square root of the trading days of the year. Oopsie, that's wrong. And then we got to divide that by 100. So we got to bring this over here. That and forecast. Boom. Now we have the annualized forecast. So this is the volatility. So it's the annualized volatility forecast. So yeah. So this is the let me change this name because it's gonna bug me. So this is the value that we needed from the GARCH model. So this is the value we actually were trying to calculate. This is the theoretical annualized volatility. This is important. I'm gonna show you why this is gonna be important to trading this option. All right. So we again have to find the price mismatches. So first we got to now find the historical volatility. Right. And to get the historical volatility, you got to get the log returns. And the way you do that is going to be NP. You got to fall in love with the NumPy package if you want to get into data. Data flows divided by NumPy package is crucial for data. Close, and then we got to shift it. All right, so now we got the log returns. All right, so now historical volatility is going to equal the log returns, the standard deviation of that. And what we're going to do is multiply it by the trading days. So that's 252, and it's the square root of 0.5. Okay. This. Okay, so this is important. These two values are what we're going to need. This is where we're going to make the money from the price difference between the two volatilities. So first, go to an options calculator. I already inputted in the price for the Tesla shares right now. The strike price, we're going to use any contract. You can find any contract, find the strike price for it. So I found one. It's going to be a call option for $222.50. This is where we're gonna need to actually put in the volatilities. Sorry about that. Had to make sure that was still running. Okay, so this is where we're going to need to input the two volatilities that we just calculated. So days to expiration for this contract is on Friday, so it's 4 more days, time of this recording. All right, so we're going to need both of these values. So first, we're going to start with the one that we calculated with the GARCH model. And if we do 100 times, this is going to be 61.6. So we go back to the calculator and we put 61.6 for the volatility. Interest rates stay the same. There is no dividend date. That's why I actually chose Tesla. That's my lazy reason why I chose Tesla. No dividend rates. Additionally, what you can also do, actually, let me just do this instead. Let me go here. Yeah. So, okay, cool. So they kind of inputted, oh, they updated the interest rates as well. Sorry about that. So we're going to do that again. So 61.6. Forgot this website does that. 61.6. Boom. So as you can see, it prices the call option at $5 and oh, it actually updated the price too. Awesome. Forgot that. The price and the strike. Well, the strike price is 222.5. Sorry. Yeah, cool. The call option is priced at 64 and 44 cents. The put option is priced at $5, and this is for the GARCH model. Now we got to get the historical one, which is 64.8, and you can, well, 0.9, you can round up. 64.9. So remember these prices here. As you can see, it actually went up by 0.3 here, and almost 1 here too. So what does that let you know? There is a spread between the two prices based on the historical volatility and the annualized volatility. And actually, if I'm not mistaken, this actually put the current volatility to, which we refresh the page for. Let me do that. This is the current volatility. This website is pretty good with that, which is at 65.79. And it's at $7. So you see what I'm saying? There's a big price difference amongst this. So with using this script, you could actually get a range of like where you would play this. Like I would buy at the annualized volume here and the current volatility at the annualized volatility there, and the current volatility has it priced at $7. I would most likely sell at the historical volatility, which would probably be around, again, let's go back to that, 64.9. Let's put that in. Yeah, I would sell at 6.9 instead of 7. So that is a good way where you can like buy in and then sell, flip the contract for that. And that's how you make money off of the price difference of options pricing strategies. Now, the script for this will be of course, in Algo World 100%. Well, it's going to be an Algo World. If you want to learn about any other options pricing, it's going to be an Algo World as well. But please rewatch this video, try to understand these statements, run through this model yourself, use different stocks. You don't have to use Tesla, use anything else. I'll also drop the link for this probably somewhere in the description of this video, so you can play with the options calculator there too. Hopefully you guys learned a lot. This is one of the simplest strategies for option pricing. My favorite one is Black Scholes. I talk about that a lot, and there's a whole bunch of other ones, but get your feet wet with this and then see if you want to enter the world of options pricing with bigger models like the ones I use. And if you are interested in learning more about other pricing models, of course, again, go to Algo World. I got you set up. You can ask me questions. I'll show you how they work, etc. All right. See you guys in the next video. Peace.